I am Rob, one of your FSCJ Adult Education Academic Tutors, and this is part one of a video series on vocabulary. This is math vocabulary, numbers for GED seekers. First up, whole numbers. In whole numbers, we have natural numbers, which are 1 and higher, 1, 2, 3, 1001, however high you wish to count. The counting numbers, this is natural numbers plus 0, so 0, 1, 2, 3, and on. There are integers. Integers are positive and negative whole numbers, but we will use these rules in a lot of places. We will talk about them elsewhere. Integers are numbers such as -10, 0, 203. You see they are whole numbers, but they have signs. Next, we have whole numbers in multiplication. We have factors, which are numbers that are multiplied together to get other numbers, which are called products. We have even numbers. Even numbers are divisible by 2, such as 2, 4, 6, 8, -10, -12. Odd numbers, which are not divisible by 2, 3, 5, -7, and on. Prime numbers, who are numbers whose only factors are 1 and itself, such as 7. Its factors are 1 and 7. A composite number is made by multiplying 2 or more numbers together, and 4 is a composite number. While it does have factors of 1 and 4, we can also multiply 2 and 2 to get 4. That makes it a composite number. Then we have parts. These are numbers that contain bits, so less than 1 or more than 1, but less than the next whole number. Fractions, which are expressed as a numerator over a denominator, or part over whole. We will talk about that more in fraction videos. Examples are 7/12 and 3/4. We have decimals. This is to the right of the decimal place, and while every number has a decimal place, we only need to write it when there is something after, such as 0.73. Also note that 0 there is to notify the reader that it is a decimal and to watch for that decimal point because it is easily missed. Percents, which come from per hundred, such as 99%, that's what that 0/0 means. That is something out of 100. There are rational numbers, which may be expressed as a fraction, such as 3/4. There are irrational numbers, who cannot be expressed as a fraction, although sometimes are approximated. The square root of 2 is an irrational number. Pi is an irrational number. We are familiar with the approximation of 3.14, but there is also 22/7 as an approximation of pi. They are irrational. The decimal repeats infinitely. Next, we have exponents, and we can look at exponents as both an operation and a number, and we are going to count them as numbers today. A power is specific instruction to multiply a number by itself a number of times indicated by the superscript, which is the little number to the upper right of the number. We can do it with variables such as a squared plus b squared is c squared from the famous Pythagorean theorem, or we can do it with a number such as 2 squared. We know 2 times 2 is 4, so 2 squared is 4. Roots go the other way and ask you what number, when written down and multiplied the number of times indicated by the root sign, gives us the number under the root sign. There is no number in that square root of 16. That means we are looking for the square root. And 4 times 4 is 16, so the square root of 16 is 4. We can also have a cube root or third power root of a number. And the cube root of 27 is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. That is the cube root of 27. So remember, the root asks us what what number, when written down that number of times and multiplied, gives us the number in the root. We are diving more into algebra now, and we will talk about variables. Variables, which are represented by letters, it does not matter which letter, although sometimes we have formulas that specify what values. We can say X, Y, N, A, B, whatever letter you wish to pick, that is the variable. It is fine. It is a number whose identity is unknown. That is in an equation to solve, and we are looking for what number makes that statement true. We will talk about equations in another video. They are also numbers whose values can change. We have already seen an example of that with Pythagorean theorem. While Pythagorean theorem applies to all right triangles, not all right triangles have the same side lengths. So those values can change for A, B, and C. This will also be used when we have graphing equations and we draw lines and curves. There are constants. Constants are numbers, and their value is fixed at whatever number. Now we are going to put the variable and the constant together in multiplication to produce a coefficient and a variable. If we do it with one number, with no addition and subtraction separating, we have a monomial, or one number. 7x, 5y, 3x squared is a monomial, as is xy squared. Then we have polynomials. Polynomials are constants with different variables, or the same variable to different powers, generally separated by addition and subtraction, and we will look at some of those more next. So continuing on our monomials, like terms are monomials with the same variable to the same power, and we may combine them, such as 7x, 5x. Note we all have x to the first power. 5, negative 12, and 32 are all also like terms because they are constants. 4y and negative 3y are like terms because they both contain y to the first power. Unlike terms are monomials with different variables or the same variable to different powers. 7x and 2y, while each are monomials because one contains an x and one contains a y, we cannot combine them. We must leave them as that polynomial. Same with 4x squared and 4x. While both contain x, that x squared means they are unlike. And the last thing we are going to talk about is notation. Scientific notation is taking a typically ridiculously large number, changing it to a ones place value number with a few decimals, and multiplying it by a power of 10. Because it is easier when you get into large numbers, particularly in things like astronomy. So if we take 3,140, we know the decimal place is after the 0, which means we must move it 3 places to the left to put our last or highest place value in the ones column. And we say 3.14 times 10 to the third is scientific notation for 3,140. This has been the kinds of numbers you will encounter in pursuit of your GED.